Hi everyone. So in this video we are going to start studying about power in EM wave. So we need to study about power that is present in a EM wave. In EM wave there is electric field, there is magnetic field. So because of those electric field and magnetic field there will be some power present in EM wave. And if it travels down through a medium, then how it propagates the power, that we are going to study now. Okay. So for studying that power we need to introduce three terms here: Poynting vector, time average Poynting vector and Poynting theorem. So we will study about these terms like one by one, and then we will see what kind of questions can be asked and how to solve those problems. So a very good topic and a very conceptual topic, also very important. If they want to frame a very good question from EMFT from this particular chapter, then they are going to frame a question from Poynting's theorem, or you can say time average Poynting vector. Okay. So first let's understand what do you mean by power. Very basic term. What is the power? Rate of flow of energy. Power is del E by del T. Right, where E is your energy. Very basic thing, right? Simple mathematical formula. I am assuming my energy is a function of space as well, it is a function of time as well. That's why I am differentiating partially. If it is only a function of time, then I would be differentiating d by dt. But if it is a function of space as well time as well, so that's why I am doing the partial differentiation. Okay. What do you mean by instantaneous power? Let's just say there is a power function which is sine square omega t. So at an instant, how much power is there? That is known as instantaneous power. Basically, this function will tell at different instant what will be the power. So what do you mean by instantaneous power? The power at a specific instant. That means power at a specific time for a time varying signal. This is a time varying signal. With respect to the time, the power will change. So this function will tell at each time how much power is there. So this is what we call as instantaneous power. If I am calling instantaneous power as P, then what will be my average power? What do you mean by average power? So instantaneous power integrated over one time period. Basically your instantaneous power integrated over one time period. Okay, this is your instantaneous power. Instantaneous power. Basically, if my power was sine square omega t, so I will integrate it over one time period. So what I'm gonna get? 1 by 2. So basically in one time period your average power is 1 by 2. This is what it shows. So this is the average power. Are you getting this point? What do you mean by average power? If you have the instantaneous power, then just integrate it over one time period, you will get your, and then divide by time period as well, then you will get your average power. Okay, this is how you get average power. Now my question is it a function of time? P average, is it a function of time? No, it is not a function of time. Why is that so? Because you are integrating with respect to time and then putting the limit of t. Basically, let's just say my pt is 3t square. So what I'm gonna do, although it is not periodic, but just I'm telling, if I integrate this and then put the limit of t and then divide by t, so what I'm getting? 3t cube by t. This t is a constant value, right? The time period will be constant. It is not a function of time. It is not a function of small t. It is not a function of time now. The answer is t square. So it is not a function of time. Small t is not there. So if you are integrating and putting the limit of t, then certainly it will not be a function of time, no. So it is not a function of time. A very important point, average power will never be a function of time. It will be a constant value, or it can be a function of space as well. If your instantaneous power is a function of space, then it could be a function of space as well, but it will never be a function of time because you have integrated with respect to time and put the limit of t. Is that clear? Very simple slide. We first understood the meaning of power, then instantaneous power, power at a certain point, and then average power, simply the integration of instantaneous power over a time period. That is your average power, right? Now instantaneous power density and average power density. So simply whatever that we have studied in this slide, per unit area, that is your instantaneous power density and instantaneous and average power density. Basically, what is your instantaneous power density? So instantaneous power per unit area. So let's just say from this particular surface area, if I am saying this is the surface area, from this particular surface area, sine square omega t, this much power was passing. From this particular surface area, sine square omega t, this much power was passing. So from a small volume of 1 meter square per unit area, how much power is passing? That is known as instantaneous power. Per unit area, how much power is passing? Per unit area, how much instantaneous power is passing? That is known as instantaneous power density. and if you integrate it over one time period, you will get average power density. So what will be the unit of instantaneous power density? That will be watt per meter square. What is the unit of power? Unit of power is watt. I hope you know it. What will be the unit of this? These will also be watt only, no? Because they are some kind of power only. These will also be watt only. But here the unit will be watt per meter square. And what will be the unit of this? Watt per meter square. So let's revise whatever that we have studied. Instantaneous power, power at a point. Average power, integrate the instantaneous power over one time period, you will get the average power. Okay. Then power density. So whatever that you have studied per unit area, that is known as power density. So instantaneous power density, that means instantaneous power per unit surface area. Average power density means if you integrate instantaneous power density over one time period and divide by time period, that will be your average power density. Is that clear to you? Okay. Now let's take this concept to EM wave. Okay. Before that, let's understand how do you calculate the total power. How do you calculate the total power? So if I am having an average power, if I am having average power density, what is this? Average power density. Average power density. That means per unit surface area, if this is the area of 1 meter square, then per unit surface area, how much average power is going? That what does that mean? That if I am saying that from 1 meter square, 1/2 watt power is going. So from ds meter square, how much power would be going? 1/2 ds. And if I integrate this over a complete time period, that means from this surface, how much power is passing, that I would get to know. So if I take the P average and then if I integrate this, since this is an open surface, so I am putting open integration and both are a vector quantity. Are you getting this point? How did I calculate that total power? Per unit surface area, average power density I knew. Average power density if I am knowing. What is the average power density? That from 1 meter square, 1/2 watt power is going. This is my P average. This is what I am saying. That from 1 meter square, 1/2 watt power is flowing. Okay, 1/2 watt power is passing. So from ds meter square, if I assume a very small surface area, let's just say this surface area is ds only. So if I assume a very small surface area, that means from ds meter square, how much power is passing? 1/2 into ds. And if I need to get to know from this complete surface how much power is passing, so what I will do? I will do the integration. So these things we have already understood. And why I am doing the dot product, that also we have understood in case of flux. So the same thing is here as well. Like if it is tilted, then less power will pass. If it is in this direction, more power will pass. That's why we are doing the dot product. So these we have already studied when we were studying about flux, right? Okay. And if you need to find it from the closed surface, then what you will do? You will do the closed line integration, right? So all these things will be slowly used when you move to this chapter. So till now we haven't studied anything related to EM wave. We are just understanding the basic term. Instantaneous power, then average power, then instantaneous power density, then average power density, and then total power through an open surface, then total power through a closed surface. So these basic terms we have understood. Now your chapter will be very easy for you. So let's understand the instantaneous power density of a EM wave. So how it is given? Instantaneous power density of a EM wave. This is known as Poynting vector. Poynting vector. This complete term, instantaneous power density of a EM wave, is known as Poynting vector. So how do we represent it? If there is voltage, if there is current, then there will be power, right? If there is voltage, if there is current, the power will be V into I. So in EM wave is made of E and H, right? So if there is E present and there is H present, then there will be power. That will be E cross H. Why I am putting the vector sign and why I am doing the cross product? Can anyone think of it? If there is a EM wave that will be traveling in a certain direction, let's just say this is your positive Z. So the wave is traveling in this positive Z direction, right? This could be any medium. This is any medium. Just this is any medium. So now in this medium, the wave is traveling in positive Z direction. Okay, the wave is traveling in positive Z direction. So now this wave is having some power in a particular direction, and that direction is given by E cross H, AE cross EH. And how much instantaneous power it is having, that is given by magnitude of E cross magnitude of H. Is that clear to you? What did I say? The instantaneous power of a EM wave instantaneous power of a EM wave, if I am representing this with P, so that is given by E cross H. Why I am doing the cross product? Because it has some power. If a wave is traveling, that will travel in a certain direction. If it is traveling in plus Z direction, that means it is having a certain direction. So your power is propagating in E cross H direction. And how the magnitude is given? So if V and I are present, power is V into I. Certain, or in the same manner, if E and H are present, then power will be E cross H. Is that clear to you? Okay. So this is your instantaneous power density actually. This is your density. Why it is density? Let's check that out. Why it is density. So this is your instantaneous power density. Instantaneous okay. So what is the unit of E? Volt per meter. How did I write it? Volt per meter. How did I write it? E is equals to V by D. Do you remember this formula? E is equals to V by D. In electrostats we are studying it. Electrostats for ECE student. I taught electrostats only for a very minute time. So there also I told you E is equals to V by D. So volt by meter. And what is the formula of H? Do you remember this formula? H is equals to I upon 2 pi r. You don't need to remember this formula. Just for dimension and unit I am telling it. Okay. So what is the unit of I? Ampere. And what is the unit of R? Meter. So what you are getting? Volt into ampere. P is equals to V into I. So that is watt per meter square. So this has a unit of watt per meter square. Okay. So I am writing down the unit. What is the unit? Volt per meter for electric field and for magnetic field ampere per meter. So what will be the unit? Watt per meter square. So the unit is watt per meter square. So this is your instantaneous power density. In a certain direction, your EM wave is propagating some power. That is given by E cross H. So this is your instantaneous power density. Now if you want to calculate the average power density, then how will you calculate? This is how you will calculate your average power density. What you are going to do? Across a one time period, you will integrate it and then divide the time period. Okay. Along one time period, I will integrate it and then divide the time period. Along with that, there is another formula which we can use, that is 1 by 2 real of ES cross HS and then this conjugate. Okay, what did I write? 1 by 2 real ES cross HS conjugate. What do you mean by ES? ES means phasor representation. These are the, if I am writing S means phasor representation I am talking about. Phasor representation. Okay, how these two things are equal, we will prove it. Do not worry about it. So, from this slide, what you need to remember? Instantaneous power of a EM wave, instantaneous power density of a EM wave is given by E cross H. Will you be able to remember this thing? Very basic thing, E cross H. Even if you don't remember, still you will be able to solve the problems. Now, average power density of a EM wave will be given by 1 by 2. Then over a time period, you need to integrate E cross H dot dt. So this is one of the way of writing the P average. Another way is 1 by 2. You take the real part of ES cross HS, ES cross HS conjugate. You need to take the conjugate of HS and then cross product with ES cross HS conjugate, and then take the real part out of it. So that will give you the average power. So one formula we have, second formula we will have another formula, so that we will see. Let's solve some problem. Let's solve this question. This is the electric field expression is given, a general electric field expression, right? E naught e to the power minus alpha z cos omega t minus beta z x cap. With respect to that, what will be your magnetic field expression? That will be E naught by eta e to the power minus alpha z cos omega t minus beta z minus theta and ay cap. What you need to calculate? You need to calculate Poynting vector. What do you mean by Poynting vector? Poynting vector means instantaneous power density. And did I tell you what do we call this function? That is known as time average Poynting vector. With the name also you can understand, time average. So instantaneous power density averaged over a time period. Over a time period, if you take the average of instantaneous power density, then that is known as average power density, or you can call it time average Poynting vector. So in the next one, what you need to calculate? Average power density. and then you need to calculate total power. What do you think? How will I calculate the total power? How will I calculate the total power? If I have the P average, then I just need to do that. If I have the P average, then I just need to do the surface integration. I just need to do the surface integration, and this is the equation of surface I am having. Is it an open surface or is it a closed surface? It is an open surface, so open integration I am going to do. So this will be your total power. Here I taught you, no? If you are having a P average with you, average power density if you are having, then just do the surface integration over the surface, which is this. This is your surface. So let's solve one by one. So first we are going to calculate instantaneous power density. So instantaneous power density of a EM wave is given by E cross H, right? E cross H. So I need to do the cross product of this. So what will be the cross product of this? This is a constant value, this is a constant value, so they will be simply multiplied. Cross product will be happening between AX cross AY. What will be AX cross AY? AZ, right? And simply multiplication of both of them. So what you are going to get? E naught e to the power minus alpha z cos omega t minus beta z into H naught, or I can write down E naught by eta. Say yes or no? H naught is E naught by eta only. E to the power minus alpha z cos omega t minus beta z minus theta n. Now can I write it down in this manner? E naught square by 2 eta e to the power minus, E naught square by mod of eta e to the power minus 2 alpha z. Now cos A cos B, cos A cos B. So can I divide by 2 and then multiply by 2? Basically 2 cos A cos B. Can I do this thing? Are you agreeing to this point? 2 cos A cos B, right? Just a second. Yeah, so what I was saying, so this expression I wrote E naught square by 2 eta e to the power minus 2 alpha z. Then what I can see is that E naught square by eta it was, so if I multiply and divide by 2, so 2 cos A cos B I am getting here. So how I can solve it? So let's keep it upward a bit. Okay, is that fine? Yes, it is fine. So E naught square by 2 mod of eta e to the power minus 2 alpha z 2 cos A cos B. What that would be? Cos A plus B plus cos A minus B. So cos A plus B. So cos A plus B. So 2 omega t minus 2 beta z minus theta n. Theta and eta you can say, theta n you can say. Cos A plus B plus cos A minus B. So this minus this, what you are going to get? Cos theta n. Is that clear? E naught square by 2 eta e to the power minus 2 alpha z cos 2 omega t minus 2 beta z minus theta n plus cos theta n. Is that clear? So this is your your instantaneous power density, or you can say Poynting vector. So this is the Poynting vector you are getting. You don't need to mug it up, neither it will be asked in your examination. If it is asked, then simply you need to do E cross H. So any expression would be given, you can do E cross H. But what will be asked in your examination? This will be asked in your examination. Time average Poynting vector. How do you calculate it? 1 by t, then P dot dt over a time period. What is P here? P is the Poynting vector, right? Or you can say instantaneous power density, or it is a Poynting vector. So over one time period I need to integrate it. So simplified expression, I forgot AZ gap. Here I will have AZ gap, right? AX cross AY will be AZ gap. I forgot the direction. So AZ gap. So simplified expression I have already written here. So instead of this expression which I have written, I will write down the simplified expression. So E naught square, अरे भाई क्या कर रहा हूँ मैं? E naught square by 2 eta e to the power minus 2 alpha z cos 2 omega t minus 2 beta z minus theta n. I hope you are able to see it. Cos A, 2 cos A cos B, cos A plus B. 2 omega t minus 2 beta z minus theta n, right? Minus theta n plus cos theta n. Okay, and then direction is also there, AZ cap. Dot dt means it is not dot product. Like t square dot dt. Is it a dot product? No, this is just the difference. This is just the integration, right? So this is not dot product. You cannot say that AZ cap dot dt. No. T square dot dt. So is it a dot product there? No. dot dt. This is how you write it, right? So now tell me one thing, what I can take out. This is a constant value, right? So this you can take out. So E naught square by 2 eta e to the power minus 2 alpha z. Along with that you can take out az cap as well. Az cap as well. Okay. Then certainly 1 by t is there. Then you need to integrate these two functions, this function and this function, with respect to dt. Plus cos theta n dot dt. Tell me one thing, this is a cosinusoid function which is a function of time. This is a cosinusoid function which is a function of time, right? If you are integrating a cosinusoid function with which is a function of time over one time period, this is the integration over one time period. You are integrating over one time period any cosinusoid or sinusoid signal. What is the value of this? Sin omega t over one time period dt, 0, because over one time period this area plus this area is equal to 0. Same goes for cos. Integration बना दिया. Same goes for cos. This area plus this area plus this area will be 0. So cos 2 omega t minus 2 beta minus theta n over one time period will be equal to 0, right? So what you are gonna get? What is this cos theta n? Is it a function of time? No, it's a constant value. Cos theta n is constant. So what is the integration of this whole quantity? E naught square by 2 eta e to the power minus 2 alpha z az cap into 1 by t. What is the integration of this whole? Cos theta n is a constant. 0 plus cos theta n. 0 plus cos theta n. So cos theta n is a constant. And then integration of dt. Integration of dt will be t only, and the limit from 0 to t. So what you are going to write? Into t. So this and this will get cancelled. So what is the answer you are getting? E naught square by 2 eta e to the power minus 2 alpha z cos theta neta az cap. This is your P average you are getting. This was your method 1. But this answer you need to remember. Okay. So what did we do? We simply did the integration. Integration of this will be cos theta n into t. How is that so? This integration will be 0. Cos 2 omega t minus 2 beta z minus theta n over one time period you are integrating a cosinusoid signal which is a function of time. That will be 0 only. Plus cos theta n dt. So cos theta n is constant, that I can take outward. So cos theta n into t divided by t. So t and t is getting cancelled. So cos theta n you are getting. So in multiplication you are getting cos theta n only. So this I am taking out, and this is the expression you are getting. Very easy to remember. E naught e to the power minus alpha z cos omega t minus beta z. This is something you remember, right? So E naught square divided by 2 eta e to the power minus 2 alpha z cos theta n. If you see it 2 or 3 times and write it down in your rough notebook, then you will be able to remember it. No doubt about that. Okay. It is not that tough. This was your method 1. What is the other method? The other method is 1 by 2 real of ES cross HS conjugate. Right? So I need ES cross HS conjugate. So I need to get the phasor representation of E and conjugate of phasor representation of H. So what will be the phasor representation of this I have written. So what will be the phasor representation of E? So what was your function which was given? E naught e to the power minus alpha z cos omega t minus beta z Ex cap. And what was your H? It was E naught e to the power minus alpha z cos omega t minus beta z minus theta n Ay cap. Can you write down very easily without even doing it in e to the power something and then taking then suppressing the time term and then taking anything without doing all these things? You can write it down. How will you write down? E naught e to the power minus alpha z. This is actually the real part. Then you would replace this part as real e to the power j omega t into e to the power minus j beta z. right? And Ax cap is certainly there. So what you are gonna remove? Real and e to the power j omega t. So what you are gonna get? E to the power minus j beta z and Ax cap. Like, it is very easy. I hope you are having the practice. How you will write down Hs? That would be, it was E naught by eta. E naught by eta e to the power minus alpha z. What you are gonna get? Only time term you will not write. So e to the power minus j beta z e to the power minus j theta n ay cap. Is that clear to you? E naught by eta e to the power minus alpha z e to the power minus j beta z e to the power minus j theta n ay cap. So what will be its conjugate? Its conjugate will be E naught by magnitude of eta e to the power minus alpha z. If you are taking the conjugate means j should be replaced with minus j. This is what do you mean by conjugate. That's it. If I am taking conjugate, that means j should be replaced with minus j, nothing else. So here, wherever you are having j, that should be replaced with minus j. So this is the conjugate I am having. Is that clear to you? Now what is the next step? Next step is I need to do the cross product. So in the cross product, only Ax cap cross Ay cap will be happening. Ax cap cross Ay cap will be happening. Okay, Ax cap cross Ay cap. So that will give you Az cap. So that you can write down in the end. Rest will be multiplied. So E naught multiplied. So E naught square by eta. Then e to the power minus alpha z into e to the power minus alpha z into e to the power minus alpha z. E to the power minus j beta z. Then e to the power j beta z and e to the power j theta n, and Ax cross Ay will give you Az cap. Is that clear to you? I just did the multiplication. E naught square by eta e to the power minus j minus alpha z and this thing I have written. This was e to the power minus j beta z. Here it is e to the power j beta z e to the power j theta n. Ax cross Ay is Az cap. So this and this is getting cancelled. Basically it is becoming e to the power 0, that will be 1. So these two are getting cancelled. So what you are getting? E naught square by eta e to the power minus alpha z minus 2 alpha z, sorry. These two will be added. So minus 2 alpha z. Then e to the power j theta eta Az cap. This is your Es cross Hs conjugate. But what is your P average? P average is 1 by 2 real part of this. So this is already real. And what will be the real of e to the power j theta n? Cos theta. This is already real. What will be the real of e to the power j theta n? Cos theta, right? So E naught square by eta e to the power minus 2 alpha z. 1 by 2 is in the expression 1 by 2 real of Ex cross Hs. E to the power E naught square by eta e to the power minus 2 alpha z, and then what is the real part of this? Cos theta n. And what is the direction? This is the direction. There you go. This is the answer. Is that clear to you? This answer and this answer both are same. E naught square by 2 eta e to the power minus 2 alpha z cos theta n Az cap. E naught square by 2 eta e to the power minus 2 alpha z cos theta n Az cap. So this is your P average. Right? So two ways are there. This will be more used. Like, this will be never used actually. This method will be never used. In the questions, if you are asked to find P average, then there is high chance that you need to apply this formula, or directly you can apply this formula. So that problem solving skills we will see. That problem solving, this is in the next part of this video, we are going to see this problem solving skill only, that how to solve these kind of equations. Like, how to solve these kind of problems. How to solve the questions on Poynting theorem, or you can say how to solve the questions of power of EM wave. So that we are going to see. But till now what we have studied? First we studied about the basic terms, then we got to know that instantaneous power density is equals to our Poynting vector only, and average power density is equals to our time average Poynting vector. So how to calculate our instantaneous power density, or you can say Poynting vector, that is E cross H. Simply E cross H we need to do. No one will ask you this. Okay, no one will ask you this. Even I am not asking you to remember this formula. Then I need to calculate the average power density, or I can say time average Poynting vector. So how do I calculate? This is the formula, or these two are the formula. So both we have used. This was our time domain analysis, and here we just took the phasors and we were doing the analysis in phasor only. Is that clear to you? and cross product this was Az cap. And what else you are getting to know, that the direction of P average, direction of, I will see the third one, but what I got to know, the direction of P average is equals to direction of propagation of EM wave, right? And it has to be the same as well. Why it has to be same? Because EM wave is propagating power. EM wave is propagating power in a certain direction. EM wave is propagating power in a certain direction, and that is equals to Az cap here. So same power, same direction, your P average will be having. P average is having the direction of EM wave only. If EM wave is traveling in Z direction, that means P average will also be in Z direction only. Same goes here as well. Both are exactly the same expression. So if I am given a particular electric field or magnetic field, from there I can get to know the power, from there I can get to know the direction of EM wave. And if I know the direction of EM wave, then I can tell you the direction of P average or time average Poynting vector. Is that clear to you? If in the examination, if they are asking what is the direction of time average Poynting vector, so that will be equals to direction of EM wave, direction of EM wave propagation. Is that clear? Let's solve the third one. So for the third one, first I need to find ds. How would I find ds? How would I find ds? So area is given 100 meter square. 100 meter square is given. So your ds will be 100 meter square, and then the unit vector ds, right? Unit vector ds. Basically, let's just say this is your surface. This is your surface. So how do you define ds of a surface? I hope you remember vector algebra. I hope you remember vector calculus. So how do you define? You take a perpendicular vector, that is your ds cap. So this ds cap I am looking for. I know the magnitude, that is 100 meter square. So this ds cap I am looking for. What do you think, which tool I am going to use to get the perpendicular vector from any surface? Which tool do we use? Gradient, right? To get the perpendicular vector from any surface, which tool do we use? Gradient. So what I'm gonna do, this was my plane. So I'm gonna create another function x plus y minus 1. If I calculate the gradient, what you are gonna get? That would be your ax cap plus ay cap. And then I need to divide the magnitude as well, because I need the unit vector, right? If this was the plane equation given, then what is the unit vector? Ax cap plus ay cap divided by under root 2. Unit vector of surface area. That means perpendicular vector to the surface. This is your surface, which is x plus y is equals to 1. If the surface was y is equals to 0, then what will be the perpendicular unit vector? Ay cap. How do I find it? Just make another function, that is y minus 0, and take the gradient of this ay cap. So your perpendicular unit vector will be in y direction, and you can think of it as well, because y equals to 0 is xz plane. Y equals to 0 xz plane, and the perpendicular unit vector will be in y direction only. So this we have already seen in a great detail when we were studying the basics, right? So now my ds is equals to 100 meter square by under root 2 dx cap plus ay cap. Okay, what do I need to calculate? The answer will be 0 actually. Why it is 0? Because what I need to calculate? P total. What my P total will be equals to? X plus y only I give, no? X plus z, yeah, that's what I was thinking. X plus z equals to 1. I do not want the answer to be 0, no? So it was x plus z. It was x plus z. Okay, the equation of plane was x plus z. So it will be ax cap plus az cap by under root 2. Here it will be ax cap plus az cap by under root 2. Okay, so what I'm gonna do, I'm just gonna do the surface integration of P average. So 100 by under root 2 ax cap plus az cap dot with e naught square by 2 eta e to the power minus 2 alpha z cos theta n cos theta neta az cap. So dot product will be happening between ax plus az cap dot az cap. So ax dot az will become 0, az dot az will become 1. Basically you need to perform this calculation. What will be the answer you will be getting? Ax dot az 0, az cap az is 1. Okay, so that will be 1. Is that clear to you? And ds is this only, 100 meter square, 100 meter square. So basically I could have put ds only here, and then if I would integrate it, then 100 meter square only I would get. Basically this is a constant value, no? I could have put ds, this ds vector I could have put as ds and then ds cap. Basically this will show the magnitude and this will show the direction, but magnitude I am directly putting because this is a constant magnitude. So 100 meter square I have already put, so there is no meaning of this integration now. Are you getting this point? ds I have erased because under root ds would give me 100 meter square only, no? Are you getting this point? Are you understanding this point? You could have directly put here that it is ds magnitude and then ds cap. Then you would put in place of this you would put ds dot ds cap. Then ds cap is your this value, ax cap plus az cap divided by under root 2. Then you would in the end ds only would be left. So if you do the integration, what you would get? 100 meter square, right? I hope you are getting what I am saying. This is a constant surface area, so I can put it directly. Then there is no meaning of integration because ds has been gone, ds is gone, ds is already gone. So basically what I am telling is that P average into ds I am doing, P average dot ds I am doing, dot product is giving me 1 and the magnitude of ds is 100 meter square. So what I am getting as the answer? So this is 1 only, so 100 by under root 2, 100 by under root 2 E naught square by 2 eta e to the power minus 2 alpha z cos theta eta. Okay, this is your P total. So these kind of questions can be asked in your examination. We will solve more problems, it will be more clear to you. This ds thing, something new I have introduced. I could have written here ds magnitude and then ds cap. So I would be doing integration with respect to ds. Then your ds cap is, what is your ds cap? What is your ds cap? Here I can get to know this is my ds cap. So ax plus az cap divided by root 2 would dot az cap would be giving you 1 by root 2. So this quantity, this complete quantity and then 1 by root 2 would come outward, and in the integration only ds would have been left. So that would give you integration of ds, that means complete surface area, and that would give you 100 meter square only. So you would be getting 100 meter square only eventually. So that I have already done. E naught square by 2 eta e to the power minus alpha z cos theta n by under root 2 would be coming out and into 100 meter square would be there. So that I have done. Okay, we will solve more problem, it will be more clear to you. When we solve the next problem, there I will not keep this 100 meter square, instead of that I will take small area ds, but things will be same. So this is your total power. So from all this discussion till now, only thing you need to keep in mind is this formula, and the other thing is this. This also you can keep in mind, this formula also you can keep in mind. So this line you need to keep in mind, other line you need to keep in mind is this, E naught square by 2 eta e to the power minus 2 alpha z cos theta neta az cap. So now I will take a break and then we will see the problem solving skills, or first we will see the conclusion, then we will see how to solve the problems. So what kind of questions can be asked and how to solve those problems, which formula we need to apply at what time. So that we are going to see in the second half of this video. So I will take a pause, drink some water, you can also do the same, and then we will proceed. Okay. Okay, so let's see the conclusion now. So what was our instantaneous power density or Poynting vector? That was E cross H. What was your average power density, or you can say time average Poynting vector? What was that? You just need to integrate over a time period and then divide by time period. So this was the formula 1 by t 0 to t E cross H, or other formula was 1 by 2 real of Es cross Hs conjugate, right? So these two are the formulas. So these two you need to keep in mind, right? And what was your total power? So if you are having the average power density, then you just need to integrate it over a complete surface. If it is an open surface, then open integration, or if it is a closed surface, then closed integration. That depends on the given surface, right? So very simple. These things we have already seen. E cross H, then the integration over a time period, and then divided by the time period, or you can write down 1 by 2 real part of ES cross HS conjugate. Very important formula. Very important. Most of the chances are there that if the question is coming from this topic, then that will be solved by this formula only. Very high chances. Very high chances. If the question is coming from this topic, then this formula will be used there. Very high chances. And what was the formula of average power density for this expression? E naught cos omega t minus beta. It could be sinusoid as well. So what is the formula that we have studied? E naught square by 2 eta. I am not writing down any expression here. So the formula we have studied, E naught square by 2 eta e to the power minus 2 alpha z. And what is your E naught? E naught is equals to eta h naught, right? E naught is equals to eta h naught. So if I put E naught eta h naught here, so eta h naught square, what you are gonna get? Eta square h naught square divided by 2 eta. This and this is getting cancelled. So 1 by 2 eta h naught square. This is what you are getting. E naught square by 2 eta e to the minus 2 alpha z cos theta n. Or what you can do, if h expression is given, then this would be the formula, right? Because just you can replace E naught. E naught is eta h naught. So if I replace it here, then this formula I will get. Eta square h naught square divided by 2 eta. So eta will be getting cancelled by eta square. So this is what you are getting, eta h naught square by 2. Now, if your medium is free space or lossless dielectric, then your alpha will be 0 and your theta n will be, or theta and eta will be 0 degree. Your alpha will be 0 and theta n will be 0 degree. So what will be the formula you will be getting? E naught square by 2 eta. And here eta is equals to eta n only. Sorry, here eta is equals to your eta magnitude, because real quantity will be. Basically, eta will be equals to eta magnitude. Here both will be same thing. So 2 eta I can write down, or what I can write down? Eta h naught square by 2. So this is something which I keep in mind. This formula I keep in mind. This formula I keep in mind, and then this I can derive there. 1 by 2 eta h naught square, right? This I can derive very easily. How I can derive it? Because E naught is equals to eta h naught. Is that clear to you? So this is the conclusion till now, right? So let's build up a problem solving skills, that how to solve problems for the given question, for the given problems. So if E and H both are mentioned, then always you are going to apply this formula. 1 by 2 real of ES cross HS conjugate. I am never going to apply this formula. Never ever I am going to use this formula to solve any problem, because this will be very time taking. So this formula I am never going to use. Okay, never ever I am going to use this formula. So either this formula or this particular formula I am going to use. Either this formula for lossless dielectric, or this is for a general medium. So these two formula I am going to use. This one or this one. So if both are mentioned, I will always use this formula. So here E field is mentioned, H field is mentioned. You need to calculate time average Poynting vector. You need to calculate P average. So how will you calculate? 1 by 2 real of ES cross HS conjugate. So can I get the ES from here? Basically, I need to get the phasors of electric field. So can I get it? Certainly I can get it. What I need to do? I just need to suppress e to the power minus j omega t. So what I will get? Ax cap plus j ay e to the power minus e to the power j beta z. This is your ES. And what about HS? So if I write down HS, then k by omega mu. K by omega mu. Ay cap. And what you need to do? Oh sorry, we are not writing conjugate here. If I am writing conjugate, then what I need to do? Plus j will be replaced with minus j. So here you are having plus j. So I will be replacing it with minus j. Minus j Ax. Then e to the power minus j omega t will be cancelled. It will be e to the power j beta z. But if I am taking the conjugate, then I will put a minus sign here. E to the power minus j beta z. Now what do I need to do? I need to calculate ES cross HS conjugate. So that will be K by omega mu. I am multiplying both of them, K by omega mu, then this quantity is cross product with this quantity. Basically I should not write it in this manner. Basically K by mu I should not write beforehand. First I need to write down this quantity, this value I need to write down, which is this e to the power j beta z, then cross product with K by omega mu ay cap minus j ax cap e to the power minus j beta z. This is constant, like this has nothing to do with direction, this has nothing to do with direction, this has nothing to do with direction, so they can come out, right? They can come out. So K by omega mu e to the power j beta z into e to the power minus j beta z, they can come out. Then in multiplication what is happening, dot product of, sorry, not dot product, cross product of these two quantities, right? So this will make 1 and this will be K by omega mu. So I need to do the cross product of this. So how will I do the cross product of this? So if I need to do the cross product, so what I am gonna write, ax ay az cap 1 j 0. Here ax cap is minus j, okay, this is 1, this is 0. So this is the cross product of this. So if I calculate the cross product, so ax line 0, ay line 0 and az line will give you something. And certainly you know that your wave is traveling in positive z direction, your wave is traveling in negative z direction, actually your wave is traveling in negative z direction. So certainly az will come in action, nothing else will come in action, az gap only will come in action. So here you can see what is you are getting. So 1 into 1 is 1 minus j into j, that will be minus j square into az gap. So 1 plus j square is minus 1 into az gap. So what you are getting, cross product is equals to 0. So Es cross Hs, what we got, Es cross Hs conjugate, what is the answer, 0, because cross product was 0. So what will be your P average? P average was 1 by 2 real of Es cross Hs conjugate. So 1 by 2 real of 0, so that will be 0 only. Very simple thing, very straightforward. Just you need to calculate this thing, then take the real part, right? We will solve more problems, it will be more clear to you. So this is how we will solve the problem in the examination. Let's move to the next part. When only one of the field is mentioned, when only one field is mentioned, either electric field or magnetic field, so mostly you will try to apply this formula, E naught square by 2 eta e to the power minus 2 alpha z cos theta n. So in this question what is the task? The task is only to find this E naught, right? Alpha you can find out, alpha will be mentioned somewhere, theta n also you can find out, but E naught you need to find out. This will be the task in this question. So let's solve different problems. So in this question, can you tell me what is E naught? E naught is 20. Okay. What is the value of alpha here? 0. There is no attenuation. So what will be theta n? That will also be 0. So what will be your P average? E naught square by 2 eta. Here I am not writing magnitude because magnitude and simple eta both are same only. So E naught square by 2 eta. What is E naught? E naught is 20 square by 2 eta. They have given free space. If they have given free space, that means 125. This is the answer. Wait a second, I need to tell the direction as well. What will be the direction? Direction will be same as the propagation. What is the direction of propagation? Az gap. This is the answer. E naught square by 2 eta e to the power minus 2 alpha z cos theta n. So theta n is 0 degree. So cos 0 is 1. This will also be 1. So E naught square by 2 eta, that is my answer. And direction, how to see the direction? Direction will be always in the direction of propagation. That's it. So if you know the direction of propagation, then you know the direction of P average as well. So this will be the direction. Is that clear? Let's move to these kind of problems. So there are 4 questions. Okay, 4 questions are there. No question is related to anyone. This is separate question, this is separate question, this is separate question, this is separate question. Now if this kind of question is given, so only electric field is mentioned. So you know this formula I am going to apply. If magnetic field is also mentioned, then it is easy, just do Es cross Hs conjugate. Now someone will say that, sir, if this is mentioned, then I can find the H field as well, and then I can apply this formula ES cross HS1 1 by 2. Sir, E is mentioned, I can find H, right? How I can find H? H will be E naught by eta cos omega t minus beta z, then write down the direction, then E naught by 2, then eta, write down the direction. In that manner I can find H as well, sir. Then I will do 1 by 2 real of ES cross HS conjugate. Yes, you can do that. But why I am teaching this? To let you know the shortcut? No. You can certainly do it, but it will take a lot of time. But here I will tell you the shortcut. So if you see these kind of questions, these has been asked in ECE examination, so anytime it would be coming in your GATE examination as well. So if you see these kind of problem, only E is mentioned, okay. So what you will say, that sir, first I will see this AX, AY. That means there are two electric field, one is in AX cap direction, one is in AY cap direction. One electric field is dancing here, one electric field is dancing in X direction, one electric field is dancing in Y direction. So both are orthogonal to each other. I will not say perpendicular to each other. Both are orthogonal to each other. Like one is dancing in X direction, one is dancing in Y direction. So in this case, if I need to find E naught, how will I find E naught then? The E naught will be under root, one is dancing in X, one is dancing in Y. So under root X square plus Y square, basically under root E naught 1 square plus E naught 2 square. So my first task will be always to see the direction. If I am having two electric field and both are orthogonal to each other, if both are orthogonal to each other, if I see the orthogonality here, then my job is done. I just need to apply under root E naught 1 square plus E naught 2 square. That's it. This will be my E naught. If I know the E naught, then what will be my P average? My P average will be E naught square by 2 eta. And here there is no attenuation, anything like that. So if there is no attenuation, so alpha is also 0, here theta in is also 0. So this will be the final answer, right? This will be the final answer. Now, is this the final answer for all the cases? Yes. Because what do I need to see? AX cap, AY cap. Now someone will say that, sir, here also there is orthogonality, sir, this is cosinusoid, this is sinusoid. Let it be. Let it be, I don't care. The main point is one is in X, one is in Y. Both are orthogonal to each other. So certainly I can apply this formula under root E naught 1 square plus E naught 2 square. So one orthogonality I need to see. So this orthogonality I am getting, this orthogonality I am getting. Someone will say that, sir, phase difference is there, 70-degree phase difference is there. I don't care. X, Y, one is dancing here, one is dancing here. If I need to get the E naught, that means if I need to get the maximum amplitude, I can simply do under root E naught 1 square plus E naught 2 square. Is that clear to you? The problem will come if this was replaced with AX cap, that both are dancing in the same direction. So their phase will come in action. Is that clear to you or not? If both are dancing perpendicularly, one is dancing in X, one is dancing in Y. If both are dancing perpendicularly, so I do not need to think, I can directly write down my E naught. So this is the answer for all the questions, right? 1, 2, 3, 4. So always my first eyes will go here. Actually, my first eye should go here. That, okay, both are dancing in the same direction, but the thing is, both should be traveling in the same direction as well, no? Let's just say, this is dancing in X. This is dancing in X and it is traveling to plus Z. Now this is dancing in Y, but it is traveling to minus Z. It is traveling to minus Z. Then scenes will be different. There you will apply 1 by 2 real ES cross HS conjugate. So first thing is, you need to check this thing. Okay, you need to check this thing. 100% chances is there that 100% I am telling that both will be in same direction only. 100%. They will never say that this guy is in this guy is in plus Z, this guy is in minus Z. They will never do that. If they do that, then what will happen? Your P average, this time average Poynting vector, will be a function of Z. So that will never happen. Okay. So certainly, if they are writing down the expression of E, so if there are two component or if there are three component cannot be there, because one will be the direction of EM wave propagation, and in the direction of EM wave propagation there can never be electric field. Are you getting this point? It will never happen that AX cap plus AY cap plus AZ cap, because in the direction of wave propagation, you can never have the electric field. So it will never happen. If they want to frame a question, they can frame it, but it will not happen that in the direction of EM wave propagation you are having some component. It has to be perpendicular, right? So electric field, if it is having AX cap and AY cap, that means here you are having orthogonality. If you are having orthogonality, then simply you can apply the formula under root E naught 1 square plus E naught 2 square. I do not care whether there is phase difference here, whether there is phase difference here. I do not care anything about that. I just need to see this thing. If I am able to see this thing, then it is okay for me. Is that clear to you or not? Right? So this is the answer for all the cases. Answer for all cases. Now let's see an example. So if this question is coming in front of me, so what do I see? Okay, this is also traveling in plus x, this is also traveling in plus x only, right? So what I need to calculate? Yeah, what will be the direction of propagation? What will be the direction of p average? In the direction of propagation only. What will be the direction of p average? In the direction of propagation. In which direction it is going? It is going in plus z direction. So az gap, right? The direction of p average will be in the direction of propagation. So it is going in plus z direction. So az gap. What about this guy? So here what do you see? Ay cap, az cap. Orthogonality is there. What do I see? Orthogonality. And if they are orthogonal, I do not care about anything. Simply I can write down my E naught. That would be under root 30 square plus 40 square. That will be 50. I do not see any attenuation. So simply now I can apply the formula. So my P average will be equals to E naught square by 2 eta. So eta I am keeping as eta only. Okay. I do not know whether it is free space or anything. So eta I am keeping as eta only. E naught square by 2 eta. What will be the direction? Direction will be in the direction of propagation. So energy is being propagated. Sorry. Power is being propagated in Ax cap direction. So this is the answer. This is the answer of P average. Very simple, very straightforward, right? Okay. Let's see the third type of problems. So do you see orthogonality here? No. So now I will see the expression. What do I see in the expression? I do not see any orthogonality here. So if I see the first question, I write down the answer of first. If I see the first one, what do I see? E naught 1, E naught 2, cos omega t minus beta z Ax cap, cos omega t minus beta z Ax cap. So that is coming common, right? So what is written actually? E naught 1 plus E naught 2, cos omega t minus beta z Ax cap. So blindly I will not go and start writing the phasors. Here I saw that there is no orthogonality, so I thought that now I need to solve by phasor, Es cross Hx conjugate and real part by 2. This is what I need to do. No. First I will see the expression. What did I get to know? That here common is coming, no? Cos omega t minus beta z is common, so E naught 1 plus E naught 2 cos omega t minus beta z Ax cap. So this is your E expression, even expression. So what you are getting? What is your E naught 1? E naught 1 is equal, sorry, not E naught 1. What is your E naught in this case? E naught 1 plus E naught 2. So what will be your P average? E naught square, whatever it is, E naught 1 plus E naught 2 square by 2 eta. Okay, medium is not mentioned, so by 2 eta, and then in which direction it is propagating? Plus z. Z cap, that's it. Okay, very easy. Like it is very, very easy. Just I manipulated the expression, nothing else. Now here there is no orthogonality. Now I cannot even manipulate the expression, right? I cannot even manipulate the expression. Why I cannot even manipulate the expression? Because this is cos, this is sine. So I cannot take anything common as well. But one thing I will see, that here these two are not perpendicular. Okay. Here these two are not perpendicular. That means space are not perpendicular. This is not orthogonal. But one thing is that these are orthogonal. Basically both are dancing in x direction only. Both are dancing in x direction. If this is your x direction, that means both are dancing in x. What do I mean by dancing? Basically this is what do I mean. That magnitude gets decreased, then it wave, then it goes. So both are decreasing or increasing their amplitude in x direction only. But the thing is, both are perpendicular to each other. One is the cos function, and other is the sine function. Both has the phase difference of 90 degree. 90 degree phase difference. So if two functions are there and both are having the phase difference of 90 degree, this is not met. If this is met, then I do not need to think anything. Ax cap, ay cap, not thinking anything. But if this is not met, then I will see this function. If they are perpendicular, then also my E naught will be under root E naught 1 square plus E naught 2 square. Why is that so? Because they are dancing in the same direction, but both are perpendicular to each other. Sinusoid and cosinusoid, both are perpendicular to each other. Are you getting this point? They are dancing on the same axis in the same direction, but perpendicular to each other. This is your sinusoid. So both has the phase difference of 90 degree. So if that is happening, then what I can do? If there is a phase difference of 90 degree, then certainly in the second equation, my E naught will be equals to E naught 1 square plus E naught 2 square. So what did you understand here? That first thing is that if E and H are mentioned, if these kind of problems are there, then I will not even think of anything, I will apply this formula. If these kind of questions are coming, I can directly see E naught here. So no doubt about that, E naught square by 2 eta, that I can apply. And direction I already know, which will be in the direction of propagation. Now if two electric field are added or two magnetic field are added, so there I will think Ax cap is perpendicular to Ay cap. 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 If I see this, I do not need to think anything. What I will do? Under root E naught 1 square plus E naught 2 square. That's it. Under root E naught 1 square plus E naught 2 square. I do not even need to look at these expression. Okay. How many phase differences there? I don't care. Just there is orthogonality. If there is this orthogonality is not available, if this orthogonality is not available, then I will try to manipulate the expression. If I am not able to manipulate the expression, then what I am gonna see? I am gonna see this thing, that cos and sine are there. That means they are having the phase difference of 90 degrees. So both are dancing in the same direction, but they are 90 degree apart. If they are 90 degree apart, then I can write down my E naught as under root E naught 1 square plus E naught 2 square. So now again here I can apply the formula. P average is equals to E naught 1 square plus E naught 2 square divided by 2 eta Az cap. Okay. Now for rest of the kind of the problem, I will always apply this formula. If nothing is clicking to me, then certainly this formula will always work. Like these questions, how you can solve? You write down E2 expression, you write down your H2 expression, then you calculate E2s, then you calculate H2s, then you calculate H2s conjugate, then you do the cross product, then you take the real part and then divide by 2. You will get the same expression. I have done it in my rough notebook. I have checked it. Then only I am telling it. Okay. You can get this answer by doing this thing as well. Okay. Which thing? By applying this formula as well. But in the examination, if they are framing this question, then they want you to think that there is orthogonality. So directly you can write down the expression. They want you to waste the time. If you waste the time, then you will feel like that, okay, I have done something. But it was very easy. Someone would be doing this thing that they are seeing the phase orthogonality. So any of these expression you can pick and try solving using ES cross HH conjugate. You will get the same answer. Okay. Now in the examination, if this question is coming, what do I see? Ax cap, no phase orthogonality, no orthogonality is there, no space orthogonality is there. I am not confusing you with the names. Basically, this is known as space orthogonality. Like they are orthogonal in space, and this is known as phase orthogonality, that they are orthogonal in phase. So they are orthogonal in phase or not? Yes, they are orthogonal in phase. Why is that so? Because they have the phase difference of 90 degree. So if they have the phase difference of 90 degrees, so what will be my H naught? H naught will be 3 square plus 4 square. That will be equals to 5. So what will be my P average? My P average will be H naught square by 2 eta. No, the formula was 1 by 2 neta H naught square, right? And there is no attenuation, so you can forget that. So 1 by 2 neta H naught square will be 5 square. So 12.5 eta, and what will be the direction? Az cap. Okay, direction of wave propagation. So this will be the answer. Very easy. So two orthogonality you can see. For the rest of the problems, you will apply this formula ES cross SS conjugate. So let's see. This expression is given, this expression is given. Ax cap, no orthogonality. sine, cos. Orthogonality is there? No. 30 degree, 60 degree. So they were 90 degree apart. But because of this 30 degree and 60 degree, now they are 120 degree apart. Or you can say 60 degree apart, basically that I need to check. So sine theta is equals to cos 90 plus theta. Is that clear? Is that correct? Cos 90 plus theta is equals to sine theta. No. Actually, cos theta is equals to sine 90 plus theta. So this I can manipulate as this. Sine plus 90. Basically, sine 90 plus theta is equals to cos theta. So this expression and this expression are same. So this has a phase of theta plus 90 degree and this has a phase of theta plus 60 degree. Sorry, not theta plus 90 degree. This has a phase of cos omega t minus beta z I am calling as theta, theta plus 150 degree, and this has a phase of theta plus 30 degree. If both are same, this is sine, this is also sine, then I can tell the phase difference now. So the phase difference between them is 120 degree, not 90 degree. If the phase difference was 90 degree, then I could have applied under root 3 square plus 4 square. Then my E naught would be 5. But here the phase difference is more. So you do not need to calculate whether it is 120 or 60. You do not need to calculate this thing. What you need to see, that sine and cos are there, they are 90 degree apart, but 30, 60. So that is making the difference. So phase difference is not 90 degree here. So they are not phase orthogonal. They are neither space orthogonal, they are neither phase orthogonal. There is no orthogonality. So now I just need to get the expression of H as well, then I will do, then which formula I will apply. So what I am writing here, no orthogonality. So now I will write down the expression of E is already there. So let's write down the expression of H. So expression of H will be 3 by eta sine omega t minus beta z plus 30 degree plus z ax cap. What will be the direction ay cap? Till now I hope you would be remembering it, right? X z. So that will be ay cap. And what about this? 4 cos omega t minus beta z plus 60 degree. So this is having x, this is having z. What will be the direction of H? That will be y only. X cross y will give me z. Is that clear to you? Right? No issue about that. So now I need to calculate ES conjugate. So what will be my ES conjugate? So no, sorry, not ES conjugate. I need to calculate ES. So what will be my ES? 3 into e to the power minus j beta z e to the power j 30 degree Ex cap. Is that clear to you? I just suppressed this term, that's it. 3 imaginary part of e to the power minus e to the power j omega t into e to the power minus j beta z into e to the power j 30. So imaginary and this omega t part has been gone. So what do you get? 3 into e to the power minus j beta z into e to the power j 30 Ex cap. There is very rare chance that this kind of question will come in the examination because it will take a lot of time, but who knows what they can ask. So 4 e to the power minus j beta z e to the power j 60 Ex cap. Now when I was a student, I had this doubt that sir this was cos and this is sine. So first should we convert into whole cos or whole sine? Basically what I am asking is that sir, first I connect this into cos and then I should calculate the phasor, or first I convert this into sine and then I calculate the phasor. No, you do not need to do this thing. Whatever that is written in that manner only you need to calculate the phasor. Okay. Like if this phasor is given, then you can get the sinusoid answer as well, you can get the cosinusoid answer as well. Someone will have a doubt that sir, you are writing this phasor. So from this phasor I can get the sinusoid output as well or cosinusoid output as well, because for getting the time harmonic vector field, what I am going to do, I will add e to the power j omega t and then take the real part or imaginary part. So if I take the imaginary part, I can get sinusoid as well. So how are you sure that it is cosinusoid? So that you don't need to think. Just whatever the expression is given, just calculate the phasor of that. That's it. So what is the phasor of that? 4 e to the power minus j beta z e to the power j 60 degree Ex cap. And what is the phasor of this? 3 e to the power minus j beta z e to the power j 30 Ex cap. Right? Now I need to calculate Hs. So first I will calculate Hs. 3 by eta e to the power minus j beta z e to the power j 30 Ex cap plus 4 by eta e to the power minus j beta z e to the power j 60 ay cap. This is how I will be doing in the examination. Okay. Then I need to calculate the conjugate. So what I will do in the examination, I will cut this, I will remove this, I will put the cut marks where there is positive, negative, I will remove this, then negative. Is that clear to you? This is how I will be solving in the examination. This is not AX cap, this is AY cap actually. Now what do I need to calculate? ES cross HS conjugate. So you can either make the matrix or how I would be solving it. So this is cross product with this. So first AX cross AY will happen. AX cross AY will happen and these two will be multiplied. These terms will be multiplied and AX cross AY. Right? So these two terms are multiplied, then what you are going to get? 9 by eta square. This is, sorry, 9 by eta. 3 into 3 is 9 by eta. E to the power minus j beta z, e to the power j beta z, both will be cancelled. E to the power j30, e to the power minus j30, both will be cancelled. AX cross AY, AZ cap. Now this will be multiplied with this, cross product of both of them. So what you are going to get? 4 into 3 by eta, so 12 by eta, minus j beta z plus j beta z cancel. 60, 30, 60 minus 30, e to the power j30, AX cross AY, AZ cap, right? Then this multiplied with this, cross product of these two. So what do you think what you are going to get? 3 into 12, 3 into 4, 12 by eta, e to the power 30 minus j beta z plus j beta z gone, 30, 60, so e to the power minus j30, AZ cap, X cross Y, Z. Then this with this, right? So 16 by eta plus j beta z, sorry, minus j beta z plus j beta z plus 60 minus 60, both are gone, AX, AY, AZ cap. Is that clear to you? Okay. So what do you think what we are getting? ES cross HS conjugate. 9 plus 16, 25 by eta, AZ cap, plus 12 by eta, AZ cap is common. 12 by eta, AZ cap is common. 12 by eta, AZ cap is common. E to the power j 30 degree plus e to the power minus j 30 degree. Right? E to the power j 30 degree plus e to the power minus j 30 degree. What is the expression of e to the power theta? Cos theta plus j sin theta. And what is the expression of e to the power minus j theta? Cos theta minus j sin theta. And if you add them both, what you are going to get? If you add them both, you are going to get 2 cos theta. So in our case, what we are going to get? E to the power j30 plus e to the power minus j30, so 2 cos 30, that is under root 3, because cos 30 is root 3 by 2. Is that clear? So this is under root 30 we are getting. So what is the final answer we are getting here? ES cross HS conjugate, that we are getting 25 by eta, AZ cap, plus 12 into under root 3 by eta, AZ cap, right? So can I write it down in this manner? 25 plus 12 under root 3 divided by eta, AZ cap. Okay. This is very easy, look. Okay, in the examination, if you have the patience, you will be able to solve. And believe me, 99.95% students will not be able to solve it. Like you can ask any of your friend who have studied EMFT and ask him to solve this question. He will not be able to solve. I can tell you. Okay. So, but it is very easy. I don't know why students are so afraid of phasor. Phasor would make problem easier, not tough. Phasor was a tool which was introduced to make our derivation easier. So we are making our derivation easier only here. So all things are becoming easy. Just cross product is there, which we are doing very intelligently, right? So what is our P average now? Our P average is 1 by 2. Real of this, it is real only. This complete quantity is real only. So 1 by 2 into 25 plus 12 under root 3 by eta, AZ cap. So this is your answer. Okay. This is your answer. Is that clear to you? This is your P average, time average Poynting vector. Okay. Let's solve this question. This is covered from Sadiku. So you need to find the total power crossing 100 centimeter square plane of this equation. 2x cap plus y cap is equals to 5. Assume non-magnetic material. So here I need to find the value of eta, because what is my P average? First I need to calculate P average, right? First I need to calculate P average. Then if I have the P average, then what will be my P total? P total will be simply the open line integration, since it is an open surface, of P average dot ds. So this is what I need to calculate. So do I have the ds here? So this time I will write ds as ds only, okay? Not so although it is constant as well, 100 centimeter square I could have written, but ds as ds only I am writing. And what will be the unit vector? If you calculate the gradient of this, what you are going to get? 2ax cap plus ay cap divided by under root 5. 2ax cap plus ay cap divided by under root 5. What is the magnitude of this? 2 square plus 1, 4 plus 1 under root 5. Okay, this is your ds. So in the end I will write down the value of ds. Okay. Now what is the direction of your P average? The direction of P average is ax cap. If the direction of P average was az cap, then I do not need to calculate anything, because I know that P average dot ds, that would be 0 only. If it was az cap, dot product of these two will be 0. But it is ax cap, so I need to calculate that. Now I need to calculate P average as well. So for P average, what is the formula? Direction I already know, so now I am gonna write down only, okay, forget about it. Forget about direction completely, I am gonna write down. So the formula is E naught square by 2 eta. There is no attenuation, so forget about the attenuation. E naught square by 2 eta cos theta n. So since there is no attenuation, so cos 0 will be 1 only. So E naught square by 2 eta, and the direction will be ax cap, in the direction of propagation only. Now eta value I need to find. If it was a free space, then eta would have been 120 pi. But it is not a free space. Why it is not a free space? Because directly you can see Vp is equals to omega by beta. Vp is equals to omega by beta. It is not equals to 3 into 10 to the power 8. So what is the value of omega you are having? 2 pi into 10 to the power 7. And what is the value of beta you are having? 0.8. So certainly it is not a free space. So now eta will be 120 pi by under root epsilon r. Why is that so? Because non-magnetic material is there, so mu r is equals to 1. So under root epsilon r I need. So how would I get under root epsilon r? So these kind of questions we have seen again and again. So this formula I am applying. Beta is equals to omega by c under root epsilon r. So beta is 0.8, omega is 2 pi by under root 7, 3 into 10 to the power 8 under root epsilon r. Okay, so this will become 10, 24, so 12 by pi. Under root epsilon r is 12 by pi. So this is actually 120 pi. So from here I am getting under root epsilon r is equals to 12 by pi. Right? Is that calculation correct? 10, 8, 24, 24, 12, 12 by pi. Okay. So under root epsilon r I am getting 12 by pi. So okay, I need to add a page. So eta value you are getting as 120 pi. Okay, I am losing my eyesight. I need to take a break. Okay, something I am having some problem in my head, so I need to take a break. You can do the calculation. I will take a break and then come back. Yeah, so where were we? So we were calculating the value of eta. So 12 by pi, right? So it will be coming out to be 98.7 ohm. Okay, this is the value of eta. Now what do I need to calculate? I need to calculate P average vector. That will be equals to E naught square by 2 eta, and the direction will be in z direction, x direction, ax cap. So what is your E naught square? E naught square is 16 by 2 into 98.7 ax cap. So let's not write down the final answer, or can we write it down? Okay, it is 81 into 10 to the power minus 3 ax cap. What will be its unit? Can you let me know what will be its unit? It is your power density, right? If you remember, it is your power density. So watt per meter square. So this is your P average. Okay, this is the P average which you are getting. What do you need to calculate? P total. So for P total you will do the surface integration of P average dot ds. So ds this time I am keeping as it is. P average is 81 into 10 to the power minus 3. What is your ds? Ds is ds only. And what is the yeah, this is your ds. Ds into 2ax cap plus ay cap, 2ax cap, and here also I need to mention the direction which I forgot. So 81 into 10 to the power minus 3 ax cap. What is your ds vector? Ds vector is simply ds, and then what is the direction? 2ax cap plus ay cap divided by under root 5. Okay, so this ds will come outward. Basically 81 into 10 to the power 3, 10 to the power minus 3, this can come outward. This ds will remain there as it is. Now ax cap dot product with this one. So what will be the answer? Ax cap dot product with this quantity. So ax cap dot ay will be 0, and if you dot product with this quantity, so what you will get? You are going to get 2 by root 5. So here you are going to get 2 by under root 5. So this also can come outward. So 81 into 2, that will be 162 divided by under root 5 into 10 to the power minus 3. And what will be the integration of ds? Complete surface area, right? Integration of ds will be complete surface area, which is equals to 100 centimeter square. 100 centimeter square. I need to write down the SI unit. So 100 into 10 to the power minus 4 meter square. So that will be 10 to the power minus 2 meter square. So here I am going to write 10 to the power minus 2. So what is the answer I am getting? 724.5 microwatt. Okay. So this is the P total you are getting. This is your P total. Very easily I have derived it. Very easily I have written it down. Very easy expression, E naught square by 2 eta I need to write down. So E naught square 16 by 2 eta. Eta I need to get to know. Since this is a lossless dielectric medium, so eta will be 125 divided by under root epsilon r. So under root epsilon r I need to get to know, so that I got to know from beta and omega value. So from there I got to know the value of under root epsilon r. Then I got to know the value of eta. So from there I wrote down the expression E naught square by 2 eta Ex cap. So 16 by 2 eta. So this is the expression. Then total power will be P average dot ds. So I could have already put here 10 to the power minus 2. Basically this is the complete surface area, 100 centimeter square. So I could have already put here, but I decided to put ds only here. Then in the end I go to know that this is complete surface area only. So this is the answer I am getting. And how do I get this unit vector? So this is very simple. Just take the gradient. Okay. Just I take the gradient 2x cap plus ay cap divided by under root this magnitude, that is root 2 square under root 2 square plus 1. So that would be 5 only. Now only one topic is left, that is known as Poynting theorem. Okay, Poynting theorem. For gate aspirants it is not that useful, it will not be asked. Poynting theorem now we are going to study. So that will tell us about the total power content, or you can say total power budget of a particular medium. So we will study about it, but I will not show you the derivation here, because with respect to gate it is not useful. Now if you want to see the derivation, then go to YouTube. Within 2 to 3 minutes you will be able to see it, or in any textbook also you will be able to see it and understand it as well within 2 to 3 minutes. Just they will take some Maxwell equation and they will just manipulate those equation and will derive it. So first let's study what do you mean by Poynting theorem, and then I will talk about the derivation. Okay, so forget about Poynting theorem. First tell me what will be the energy density due to electric field in a particular volume. How much energy will be there due to electric field? So for there is a formula which should be studied in electrostat, but we did not study electrostat as a ECE student. So we did not study electrostat in much deeper manner. So energy density due to electric field, energy density due to electric field in a particular volume is given as 1 by 2 epsilon E square joule per meter cube. It is energy per meter cube. So per unit volume how much energy is there, that is 1 by 2 epsilon E square. Per unit volume how much energy is there because of magnetic field, that is 1 by 2 mu h square. Basically what do they mean to say is that, let's just say this is some volume. Now in this volume some electric field is there, some magnetic field is there. Now because of these electric field and magnetic field, what will be the energy? So 1 by 2 epsilon E square joule per meter cube per unit volume plus 1 by 2 mu h square joule per meter cube per unit volume. Okay, now this is the medium which we are talking about, right? This is the medium which we are talking about. Now let's just say this medium is having some conductivity. It is having some conductivity. So in a resistor, if I current flows, so there will be some power dissipation. Power dissipation means power loss. The resistor will eat up some power. In a resistor, if some current flows, there will be some power dissipation. That means the resistor will eat up some power. That is equals to I square into R. Similarly, if in conductive medium, if in the conductive medium, if there is some electric field, then there will be some power loss. In conductive, I should not say conductive, any medium, it could be lossy dielectric as well. If it is having some sigma, then certainly there will be some power loss. Why is that so? Because we saw it, no, that there was a EM wave, and when it was going into some conductive medium or some medium having some conductivity, so it was losing its amplitude. So certainly there was some power loss. So it is losing its power. So if any EM wave is traveling, if any electric field or EM wave is traveling into this medium, then it will lose some power, and that power loss is known as ohmic power loss. Ohmic power loss. So that is given as sigma epsilon square. What will be the unit of this? Sigma epsilon square. So sigma E into E. What is the sigma E? J. J into E. What is the unit of J? Ampere per meter square. And what is the unit of E? Volt per meter. So unit is watt per meter cube. So this is actually density, right? This is density. So per unit volume, sigma into E square, that much power will be lost. Are you getting this point? Per unit volume, sigma into E square power will be lost if there is electric field present. So in a box, if electric field is present, then it will have some energy. It will have some energy. That will be epsilon 1 by 2 epsilon E square. If there is magnetic field, then there will also be energy. What is that? 1 by 2 mu h square. Both energy are defined per unit volume. Is that clear? If there is some conductivity, if the medium is having some conductivity, if your box is having some conductivity and there is electric field present, so certainly there will be some power loss, and that power loss is given by sigma E square. If this sigma is 0, then certainly there will be no power loss, and your amplitude of electric field, or you can say amplitude of EM wave, will remain as it is. Is that clear to you? Yes, it is clear to me. Okay, it is clear to you as well. Now let's study about the Poynting theorem. So what this Poynting theorem states? So this is like, assume there is some medium 1, there is some medium 1, then you are going into this medium. This medium is having, this is some medium, this medium is having sigma, mu and epsilon, its own sigma, mu and epsilon. What is the value of sigma, mu, epsilon? That I don't know. Previously there was a EM wave, now it is going into this medium. Once it goes into this medium, so this EM wave is a component of E and H, right? E plus H. Here E is also there, H is also there. So once it goes into this medium, so here also there will be some EH. Since there is some conductivity, so I am telling that there will be some loss of magnitude. Okay, some power loss is there. So can you let me know, this is your EM wave. So this EM wave is having E and H, right? This EM wave is having E and H. So what will be the energy density of this wave in this particular box? Total energy density you need to tell me. So if I need to write down the energy density, so because of the electric field, the energy density will be half epsilon E square. And because of the magnetic field, the energy density will be half mu h square. This is your energy density. And if I need to write down the power density, then what do I need to do? This is your energy, right? If I do dou by dou t, what I am gonna get? This E will be a function of t, H will be a function of t. Basically, E is a function of t. H is also a function of t. If I differentiate with respect to t, partial differentiation I am doing. So basically, this E can be function of x, y, z and t, right? This will be function of space as well. This will be function of time as well. This can be function of space as well. This can be function of time as well. Both can be different functions. So this I am plotting by G, not by F. This I am denoting by G. Both can be different functions. Okay. So partial differentiation with respect to time, if I do, I will get power. In the first page only we saw this. What is your power? Power is the change rate of flow of energy. So dou by dou t into energy, that will give me power. So this is the power density. This is your power density in this box per unit volume. What is the unit of this? watt per meter cube. This is the power density per unit volume. In the whole volume, if I need to calculate the power, what do I need to do? Dot dV. In the whole volume, this much power is there. Is this expression correct? No. Why is that so? Because of sigma also there will be some power loss. Because of sigma there will be some power loss, right? This is because of your, this power is because of your electric field and magnetic field. Since there is sigma as well, since there is electric field as well, so certainly there will be some power loss, which is sigma E square. So in this box, initially there was no energy, there was nothing. This box was completely blank. Then some EM wave came. EM wave came, so it was having E as well and it was having H as well. Since there is E and H both are present, if E and H both are present, so E will have some energy density, that is half epsilon E square, and H will have some energy density, that is half mu H square. This was your energy density. If you need to get the power, then what you need to do? Partial differentiate with respect to time. Because what is power? Rate of change of energy. So dou by dou t, this is the power. Now this is the power per unit volume. So if you need to calculate the whole power, this is what you are doing. But again, because of your sigma, there will be some power dissipation as well. So what is that power dissipation? That is sigma E square. Sigma E square. But what is this? This is power dissipation per unit volume. Power dissipation per unit volume. If you need to calculate the total power dissipation, so what you are going to do? dV. So can I write it down in this manner? Plus sigma E square and then dV of this complete. So this is the total power of your box. In the box there is electric field present, there is magnetic field present. Because of electric field there was power density half epsilon E square. Because of magnetic field there was power density. Then you differentiated with respect to time, partially differentiated, you got the power per unit volume. Along with that, because of sigma there will be some power dissipation, that was sigma E square. But sigma E square was also what? Sigma E square was power dissipation per unit volume. So you need to differentiate with respect to dV. Is that clear to you? Right? So this is the total power. This is, now this expression is showing your total power of this box. Total power of this box. In this box, whatever the total power is that it is showing. Now, is this the instantaneous power or simple power? What do you think? E is a function of time, H is a function of time. This is complete is a function of time. So at an instant it is telling us the power, right? Here E will be a function of time, H will be a function of time, this E will also be a function of time. So this complete expression is a function of time. So at an instant it is telling us the power. So this is your instantaneous power. Instantaneous power. So this is your instantaneous power. Now for a EM wave, how I can define my instantaneous power? E cross H. But this is my instantaneous power density. If I need to calculate the complete instantaneous power, what do I do? Dot ds and then take the integration. This was your E cross H was your power density. E cross H. Do you remember that? Do you remember the unit? Watt per meter square. The unit was watt per meter square. If I need to calculate the complete power, if I need to calculate the complete instantaneous power, this was your instantaneous power density. If I need to calculate the complete instantaneous power, then I need to do the integration with respect to ds. So with respect to ds, I am doing the complete integration. Since it is a closed surface, so I will put the close sign here. This is known as your Poynting theorem. This statement is known as your Poynting theorem. But one more thing here. What is that? Here minus sign will come. So what this is denoting? You are having a box, right? I am having a box. Okay, this light I am having. So let's assume this as a box. So initially in the box there was no energy, there was nothing, no power, nothing. Then EM wave came. Because of the EM wave, electric field and magnetic field were present. Because of electric field there was some power, because of magnetic field there was some power, and because of the conductivity there was some power loss, which has been written here. Okay. So this was the total power content of the box. Now, do you know the conservation law of energy? The energy is always conserved. So whatever that energy that is getting in, that has to flow out as well. How much energy is flowing out? This much energy is flowing out, right? Because your EM wave was containing this much of power, this much energy, sorry, I should say this much power is flowing out. Your EM wave was containing this much power. Do you agree to this point? Because E cross H, this is giving me instantaneous power density, and if I do ds, so total instantaneous power it is giving me. So your EM wave was containing this much total instantaneous power. So this will flow out as well, no? This is inside the box and this is flowing out. So negative sign would come. Negative sign is just showing that this power is flowing out, nothing else. Okay. In textbook, what you would find is that this negative sign is taken at this side. This negative sign is taken at this side. Then they say that this is power loss, so that's why it is negative. And this they say that this is the rate of decrease of electromagnetic power, or you can say electromagnetic energy density. Rate of decrease of electromagnetic energy density. So I don't think that represent anything like conclusive. For me, this is the conclusive statement. The conclusive statement is that there was a box. In this box there was no energy. Then E and H came, so it generated some power because of E, because of H. We wrote down the power, and there was some power loss as well. So this was the total power of this box. Now this power will flow out as well, but since they are conserved, so I am putting it equal. But I will have to put the negative sign, because that is the power. This is the power which is flowing out, because your EM wave will carry this much power. So this is the power that is flowing out. So this is what I understood by this statement. The rate of decrease of EM wave energy, that is also correct, and since that is a power loss, then they can put negative sign. Basically this negative sign would be put here. Okay, then they will show this negative sign here. Also they will show this negative sign. This negative sign will be put here, and they will tell that this is showing the rate of decrease of EM wave power. So from that I do not make anything conclusive, but this is the, like, this is my analysis. I think this is what is happening. That's why we are writing down in this manner. Okay, so this will not be asked in your gate examination. If they are going to ask anything, then they can ask this statement. So this statement, can you see it? Can you write it down? You will think E is there, H is there, so power I can write down. So sorry, energy density I can write down. So from there, if I need to get the power, dou by dou t. From there, if I need to get the complete power, so dot dv. But there will be some power loss as well. What is that power loss? Sigma E square. But that is the power loss per unit volume. So if I need to get the complete power loss of the volume, dot dv, and that will be equals to EM wave, how much instantaneous power EM wave carry, E cross H. And for the complete like from this surface, how much power is flowing out, from this surface how much instantaneous power is flowing out. If I need to find that thing, so what I'm gonna do, dot ds. And from closed surface I need to find out, that means how much entered here and how much flown out here. If I do the closed surface integration, that means from the complete closed surface, how much power is flowing out. From the complete closed surface, how much power is flowing out. This is what I am calculating by E cross H dot ds. So from the complete surface, this much power is flowing out. So that's why I have put a negative sign as well, and I am doing the closed line integration. Sorry, not closed line integration, closed surface integration. So that is my Poynting theorem. Proof of it you can see anywhere on YouTube. Not important for gate aspirant. No one will ask you. They will just write down some Maxwell equation. They will manipulate those Maxwell equation, and eventually you will get this statement. Okay. So no need to worry. No one will ask you this in the examination. Just maximum they can ask this statement. Okay. So I hope it is clear. So now we have covered the Poynting theorem part as well. Poynting vector, time average Poynting vector, everything related to the power we have covered now. So I hope now things are clear to you. Now we will move to the next part where we need to study boundary condition. Then we will see the reflection and transmission of EM wave, normal incidence and oblique incidence. With respect to that, we will study parallel polarization and perpendicular polarization, and then another polarization also we will study. So that we are going to see now. So this is first half of the EM wave. Okay, EM wave is not completed. First half of EM wave is completed. That means it is the interval. If EM wave is a movie, then this is the interval of EM wave. So another half is remaining, that will also come now. Is that clear to you? So if you want to see the derivation anywhere in any textbook, you can see the derivation. Okay, or even in any YouTube video, if you just write down derivation of Poynting theorem, you will get the derivation. They will just manipulate the statement of Maxwell equation, and then from there they will get this answer. So simple mathematics will be there, you can get it there. Okay, yeah, thank you very much. If you found this helpful, you can write down any comment or you can like it. Thank you very much.